Hey guys, how's it going? Welcome to my video on Math 20-1 course. Our unit is sequences and series, and this video is on the topic called arithmetic series. Okay, so let's get into what this is all about. All right. So guys, this is kind of an extension from an existing note outline that I have. So this example 10 right now for the unit. Determine the sum of each series, okay? So guys, it's a pretty straightforward question asking 1 plus 5 plus 9 plus 13 plus 17 plus 21. So I'm just going to fire all this into my calculator. And the answer is 66. So just the thing we want to notice about over here, guys, okay, I asked you to kind of find the sum of a series, but I didn't really define what series is, so the definition could be right over here. Well, when we talk about an arithmetic sequence is a list of terms that any two terms, I'm going to say any two consecutive terms, have a common difference. Okay, so if you list a bunch of numbers, guys, we talked about this in our last topic, arithmetic sequences. If you subtract any two terms, you're always going to get the same difference between any two terms. So in this case, this is what we call an arithmetic series. Okay, now what an arithmetic series is the same thing as a sequence, except instead of just listing the terms, you're actually adding the terms. Okay, so an arithmetic series is the sum of an arithmetic sequence. Sorry guys, can't spell this morning. Okay, so in this case, this is an arithmetic sequence. We're just going to add all those terms up together. Okay, so over here, for the second one, similar idea. Now this dot 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 means we're just going to extend this this series in between. Now hopefully what you can see, guys, 16, 13, 10. It's like we're counting down by 3 every time. So what I'm going to do over here, I'm just going to write the full thing out here. Guys, there is going to be a better way to do this question. We'll teach you how to do that later on. All right, so we have 16 plus 13 plus 10 plus 7 plus 4 plus 1 minus 2 minus 5 minus 8 minus 11 minus 14 minus 17 minus 20 minus 23. Answer is negative 49. Okay. Now, ideally here, guys, part of this unit is like if we have a situation like we have in B, we want to kind of be able to determine some formulas that we can use to be able to calculate this. Okay, now this is from 16 to negative 23. Imagine if I had 572 all the way to negative 1,827, like that, right? So it's having a big long series like that would be completely impractical to be able to do by hand. So we need to be able to figure out some formulas that we can generalize to do it for any of them. So in the next one, we have what we call the arithmetic series formula. Okay. Now, what I'm gonna do this as an example, guys, and I'll kind of prove it afterwards. But let's suppose we had just a very simple one. Let's say I had 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14. Okay. Now, here's the way we're going to do this proof. Okay, here's one series. What I'm going to do is I'm going to rewrite the exact same series directly below it, but except I'm going to do it in reverse order. and I'll show you why this works in a second here. So now I'm just going to go from 14 down to 2. Now, if I add these two series together now, I get 2 plus 14 is 16, 4 plus 12 is 16, 6 plus 10, and everything's going to be 16 when I add these guys together. Okay, or I have 1, 2, 3, 4, 5, 6, 7 16s. But then what I need to do is I need to divide it by 2, because really what I've done is I've added this series twice. Okay, so if I just want to figure out the series of this once over here, it's 7 plus times 16 divided by 2, which gives me an answer of 56. Okay, so just kind of verifies that, guys. I'm just going to do my calculator. 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14. Answer indeed is 56. Okay, so the idea behind this over here is if we're adding up 2 is the first term and 14 is the last term. Okay, now n is going to be the number of terms in the sequence. Here's what our formula is going to be. Sn equals n over 2 t1 plus tn. Okay, so if I come back to this example over here, okay, this is like t1, t2, t3, t4, t5, t6, t7. Okay, so in this case, I want to figure out, well, what is S7? Now, S7 means the sum of 7 terms. Okay, so term 1 plus term 2 plus term 3 plus term 4 plus term 5 plus term 6 plus term 7 over here. Okay, now in this case, our n value is 7, so it's going to be 7 over 2. T1, this is the first term, and this is the last term. Okay, so we have 2 plus 14. Okay, now if you see over here, this is exactly what we did in this calculation over here, right? 2 plus 14 is 16 times 7 divided by 2 divided by 2, right? And so this is how we get our answer of 56. Okay, so guys, there's another version of this formula. We're going to get there in a second here. Let's do a few examples. Okay, so in this case over here, it says find T10 and then S10. Okay, so I'm going to do this question the long way first, guys, and I'll show you the kind of the shortcut afterwards. So 4 plus 11 plus 18. Hopefully you see, guys, a common difference is 7 here. So it's plus 25, plus 32, plus 39, plus 46, plus 53, plus 60, plus 67. Okay, so that means this over here is T10. This is T1, and we know there's 10 terms here. We know that n equals 10. So if I'm figuring out, so I know that T10 equals 67, T1 equals 4, n equals 10. Our formula is Sn is n over 2, T1 plus Tn. Okay, so it means S10 is 10 over 2, 4 plus 67. I'm just going to do this right on my calculator. 10 divided by 2, bracket 4 plus 67 is 355. Okay, so that's our answer there. Now here's the shortcut, guys. We're not going to write this out every single time. If I ask you for a T50 or S55 and T55, that would be a lot longer. If I ask you for T1024 and then S1024, I would never do that by hand. Okay, so the way we figure out Tn is we're going to refer back to our last section. Okay, so arithmetic sequences. This formula is on your formula sheet as well, guys. Tn equals T1 plus n minus 1 d. So that means T10 equals T1, which is 4. Our common difference is 7, so it's 7 minus 1 My apologies, guys. I messed this up. My n value is 10. So this is 10 minus 1 times my common difference of 7 equals 4 plus 10 minus 1 is 9 times 7 is 63. 4 plus 63 is 67. Okay, so this is another way that we can get the value of T10 is using this formula over here. Okay, now for this guy over here, I'm going to use this formula to figure out what this guy is. Okay, so Tn is T1 plus n minus 1 times d. And I know that T1 is 58, n is 10, d equals negative 8. 58 to 50 to 42, these are going down by 8 every time. Okay, so that means T10 is T1, 58, plus 10 minus 1 times negative 8 is 58, plus 9 times negative 8 is 58 minus 72, which is negative 14. So that means T10, our 10th term, is negative 14. Okay, so we have, all right, so there's T10. Now we need to figure out what Sn is. Sn is n over 2, T1 plus Tn. Okay, so we know that n equals 10. That means T10 equals negative 14. We calculated that in this step over here, and we know that T1 equals 58. So that means that S10 is 10 over 2, 58 plus negative 14 is 5 times 58 minus 14 is 44. 5 times 44 is 220. So the sum of this series is going to be 220. Are you recording? Yeah, I'm recording right now. All right. So what we do over here, guys, I'm going to expand this out and show you a different version of this formula over here. Okay. So the arithmetic series formula is n over 2 times T1 plus Tn, but we also have a different formula for Tn, which is this guy over here. Okay. Now, to get the other version of this formula here, guys, we're going to make a quick substitution. I'm going to do this over here, and we're going to substitute it in for Tn over here, because Tn equals this, and then Tn equals this. So that means Sn equals n over 2. We have T1 plus n minus 1d is n over 2. T1 plus T1 is 2T1 plus n minus 1d. Okay, so this is like the second version of your form of your arithmetic series formula. Okay, so we'll use this one sometimes, and guys, actually, it's going to be easier to use this for these questions over here. Okay, so now what's different over here? The first formula is helpful if you know the number of terms and you know the last term. Okay, well, the second formula is going to go is like, well, in this case, I don't need to know the last term. I don't need to know Tn. I just need to know the first term, the number of terms, and the common difference. Okay, so in this formula over here, we know that n equals 10 because we're T1 and S10 over here. We know that our common difference is if I go 2 minus 12 fifths like this is the same thing as like 10 fifths minus 12 fifths, which is negative 2 fifths. So this is negative 2 over 5 for my common difference. Okay, and I know that T1 is 12 over 5. Okay, so if I'm going to apply my second, my second formula here, we know that S10 equals 10 over 2. 2 times 12 over 5 plus n minus 1d. n is 10. My common difference is negative 2 over 5. Okay, so hey guys, now it's going to use a calculator. We're going to put this in exactly the way we see it over here. 10 over 2, bracket 2 times 12 over 5. Close that bracket, plus bracket 10 minus 1, bracket negative 2 over 5. And I get an answer of 6. Okay, so this is how the second version of the formula looks over here. Okay, guys, I'm going to skip this example over here because I think there's definitely a typo with this example over here. It's not working properly. Okay, all right, so let's look at example 13. An athlete in training does push-ups every day. Each day he does 5 more push-ups than he did the day before. On day 12, he does 120 push-ups. How many push-ups did she do he do on day 1? Okay, so the idea is we have day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we have 120. Okay, so this would be like T12, and this is T1. So we're looking for this guy over here. Okay. Now the idea is he does 5 more push-ups than he did the day before. Okay, so working backwards here, this is going to make an arithmetic sequence question, guys. So we're just listing the terms here. T1 plus n minus 1d. Okay, so if I'm going to use this last term here, that means that T12 equals T1 plus 12 minus 1. And I know that my common difference here is 5 because he does 5 more than he did the day before. Okay, so that's my common difference. So T12 is 120 in this case equals T1 plus 12 minus 1 is 11 times 5. 120 equals T1 plus 55 minus 55 minus 55. 120 minus 55 is 65 is T1. Okay. For part B, how many push-ups will she do on day 42? So we want to extend this sequence over here to day 42. That means I want to go T42 equals T1 plus 42 minus 1. Common difference is 5. Sorry guys, my T1, we know our T1 is 65, so that means T42 equals 65 plus 42 minus 1 is 41 times 5. I'm just going to put that in my calculator. 65 plus 41 times 5 equals 270 push-ups on day 42. How many push-ups will she have done in total up to and including day 42? So this is going to make the sum of all these push-ups over here. So guys, if we're looking for a sum, that means we want to use our series formula. Okay, so our series formula is I'm going to do this question twice here, guys. I'm going to use both formulas and show you that they both work. Okay, so for the first one, we want S42 equals 42 over 2. T1, we calculated was 65. Day 42, our last one, so T42 is going to be 270 equals, calculator time, 42 divided by 2, bracket, 65 plus 270. Guys, I'm just putting this expression here into my calculator, and the answer is 7,035. If I use my second formula here, I have S42 equals 42 over 2. 2 times 65 plus 42 minus 1 times my common difference is 5. And I'm going to put this expression in my calculator, 42 divided by 2, bracket 2 times 65 plus bracket 42 minus 1 times 5 also gives me an answer of 7,035. Okay, so we can use either formula over here. Now, in which situations do you want to use each? The first formula here, guys, is better if you know the first term and you know the last term. I think this formula is easier to use. Okay, but the second one's gonna be more thing. If I don't know the first term, sorry, if I don't know the last term, but I do know the common difference, I can say the second formula is going to be easier to use. Okay, example 14. This is a nasty one. The sum of the first 3 terms of an arithmetic series is 27. The sum of the first 7 terms of an arithmetic series is 133. What are the first 4 terms of the series? Okay, so here's what we have over here. We have T1 plus T2 plus T3 equals 27. And then I have T1 plus T2 Okay, so this is saying that S3 equals 27, and this is saying that S7 equals 133. Guys, for this question, we're going to use the second formula, which is Sn equals n over 2, 2t1 plus n minus 1 d. Okay, now let's apply this formula for S3. So if this was S3, that would be 3 over 2, 2t1 plus 3 minus 1 times d. Now we know that S3 is 27, so I can make this substitution here. 27 equals, and if I multiply this through to here and here, 3 over 2 times 2 is 3t1. 3 minus 1 is 2 times 3 over 2 is 3t. So we have 27 equals 3t1 plus 3d. Okay, now guys, right now I have one equation with 2 variables, so I can't solve for either of these guys yet. We'll come back to this one in a second. So the same thing for S7. Okay, so S7 is 133. So I'm going to make this substitution here. 7 over 2 times 2t1 is 7t1. 7 minus 1 is 6. 6 times 7 is 42. Divided by 2 is 21d. Okay, so now we have this question. Now guys, what we're going to do here is I'm going to arrange these 2 equations and stack them over top. And now what we have is a system of equations that we need to solve. Okay, guys, I think I'm going to solve this one by elimination. So what I'm going to do is here is I'm going to multiply this guy times 7. That's going to give this 21 here and here. So we get 133 equals 7t1 plus 21d. 7 times 27 is 189. 21t1 plus 21d. Subtract 133 minus 189. We have negative 56. 7t1 minus 21t1 is negative 14t1. The d's cancel out. And now if I divide by negative 14, I get 4 equals t1. Okay, so we've solved for t1. Now I'm going to go to either one of these formulas here. I have 133 equals 7t1 plus 21d, and we know that when t1 equals 4, okay, 133 equals 7 times 4 plus 21d. going to solve this equation here. Oops, minus 28 minus 28. 105 equals 21d. Divide by 21, and we get 5 equals d. Okay. All right, so we figured out what our T1 was, and we figured out what our D was. So if I'm looking at this sequence over here, the question's asking us for what are the first 4 terms of the series. Well, our first term we figured out was T1 is 4. If our common difference is 5, that means this is a 9, this is a 14, and that means this is a 19. So 4, 9, 14, 19 are going to be the first 4 terms of the series. Okay, very similar type of question over here, guys. Just the numbers are a bit different, so giving us a bit more practice for this one over here. I'm just going to do this one a bit faster here. Sum of the first 6 terms, that means S6 equals 72. We know that N equals 6. Okay, so, and we have our formula is 6 over 2 is 3, times T1 is 6T1. 6 minus 1 is 5. 5D times 3 is 15D, like this. Okay. We know that S10 is 40, and that means that N equals 10. So the same thing with this one over here. S10 is 40. 10 over 2, 2T1 plus 10 minus 1D. 40 equals 10 over 2 is 5 times 2T1 is 10T1. 5 times 90 is 4D5D. Just going to stack these 2 equations like this. Okay, I'm going to multiply this equation times 3 because 15 times 3 is 45, and that means these guys match up. Three times 72 is 216. All right, all that to figure out that our first term, T1, is negative 22. And let's figure out what our common difference is now. Okay, so we know that 40, so this work over here, 40 equals 10T1 plus 45D. So I'm going to plug in negative 22 in for T1. Sorry guys, I'm getting a weird answer here. I just wanted to go double check and make sure that my work is okay here. Nope, I think we're good. Okay, so guys, I got a common difference, which is not a nice number here, of 52 over 9. Okay, so yeah, it's kind of an uglier number over here, but sometimes we're going to get that. So if I have negative 22, my first term is negative 22. My second term is, I'm going to add 52 over 9. And that gives me, I'm just using my calculator for this, guys, 146 over 9. Do that again. We get negative 94 over 9. One more time. And we get negative 14 over 3. And those are going to be our first 4 terms of this series here. All right, guys. Thanks for tuning in for this one, and I will see you guys in the next video.